8.5 notes. Let's get these down here. Area of a circle. Okay. All right. So here's the formula for area of a circle. You take the radius, you square it, and then you multiply with the number pi, which we represent by that symbol right there. That's the pi symbol right here. Okay. All right. So what does r represent in this formula? R is the radius. All right, guys. So let's talk about a circle though before we actually get into the formulas here. So I'm going to make two circles here. The two circles here on the screen so we could talk about circles. Just so we could talk about, make sure we understand the difference between a radius and a diameter, okay? All right, so if I put a point in the center of each circle that I have right here, on the circle to the left, if I draw a line segment and that line segment has one end in the center and the other end right on the circle, that line segment is called a radius. So a radius goes through half of the circle, right through the center, but only half of it. A diameter goes right through the center of the circle, but the ends of the diameter, both ends, are on the circle. Okay, so a diameter is all the way through the whole part of the circle right here. D-I-A-M-E-T-E-R. Diameter or diameter, radius. Radius goes through half of the circle, right through the center. Diameter also goes through the center of the circle, but the diameter goes through the entire circle. The ends are both on the circle there. So to find the area of a circle, we take the radius to the second power, and then we multiply it with the number pi. So as you see in example number 1 here and number 2, we are going to find the area of both of these circles. In the smaller circle, the radius is equal to 12. In the circle on the right, the radius is equal to 9. So that means to find the area of the circle on the left, I am going to take the radius, which is 12. I am going to square it, and then I'm going to multiply it with the number pi. Okay, so you square the number first. 12 squared is 144. And then I'm going to multiply the number 144 with the number pi. But here's what we're going to do. You will not use 3.14 for pi. You will use pi for pi. So if you multiply 144 times pi, the way that you write your answer is you don't multiply that out. You do not go 144 times 3.14. Okay? Don't do that. No. Don't do that right there. So what's the area? How do we write the area? It's simple. You write the area with the symbol pi in your answer. You would say the area of the circle is 144 pi. Don't multiply it out. Okay? Next example, for finding the area of this circle, we have a radius, which is 9. So to find the area, I'm going to multiply the radius squared, or the radius to the second power, 9 squared, and then I'm going to multiply that number with pi, the number pi. Square the 9, which is 81, and then I'm going to multiply 81 with the number pi. So that gives me an area, and once again, do not multiply 81 times 3.14. You just put the answer with pi in your answer. So the area of the circle is 81 pi. Okay, and that's all you have to do. We know that pi is about 3.14, and if we really wanted to multiply it out, we could. But we are writing our answers, everything we're doing today with circles, always with pi in your answer. Okay, so now let's move over to circumference of a circle. So circumference of a circle, hopefully you know what that is, but here is what circumference is referring to. Circumference is the distance around an entire circle. Okay, area is how much space is inside the circle. Circumference is distance around the circle, okay? And to find the circumference of a circle, there is a different formula that you use to find circumference than you use for area, all right? And that makes sense because they're different things. Circumference is like perimeter of a circle. Here's how you find it. You take the number 2. You multiply it with the radius, which we represent with r, and then you multiply that with the number pi. So the way you find circumference of a circle is you go 2 times the radius times the number pi. See the circle down here where we have 8 miles here, okay? And that means, and that is a radius. So in this particular circle, we know that the radius is equal to 8. So that means my circumference, which I'm going to represent by the letter C in math we represent by circumference. I'm going to take 2, multiply it with the radius, which is 8, and then I'm going to multiply that with the number pi. Okay? And when I multiply this out, do not multiply 3.14 for pi. Leave pi as pi. 2 times 8 is 16. Which means I'm not going to multiply 16 times pi. My circumference of this circle would be represented with pi in the answer. So the circumference is 16 pi. Okay, the next circle right here, we have this 6.2 miles, and that is a radius. So we know that the radius of this circle is 6.2. So to find the circumference, I'm going to use the formula. 2 times the radius, which is 6.2, times the number pi, which I represent with the pi symbol. I will not multiply out. Pi is 3.14. Multiply 2 times 6.2, that is 12.4. So I get 12.4 times the number pi. And once again, we are not multiplying out pi, so the circumference of this circle is going to be 12.4 pi. Okay? Please do not multiply 3.14 for pi. All right, so now that leaves us to what is an arc? An arc, A-R-C, not A-R-K, all right? So an arc, as you can see, is any 2 points on a circle determine a minor arc and a major arc, all right? So an arc is, if you think of what an arc is, this is a good representation of an arc. An arc is the crust part of a pizza, okay? Crust part of pizza. So if you thought of a pizza and you just took away everything except for the crust, you're looking at the arc of the pizza. So if you think of a circle as pizza, the arc from A to B would be just that part of the crust of the pizza, okay? And what we're going to do is we're going to go over how do you find arc length of a pizza, or of a circle, excuse me. I got pizza on my mind. In other words, how long, what is the length of a piece of crust on a pizza? And the way that you find that is there's a very specific formula. The formula is 2 times the radius of the circle, which we represent with r, times pi, which we represent with the pi symbol, times the fraction x over 360 degrees, okay? And in this equation, that x right there represents the measure of the central angle, of measure of the central angle. Okay? So this formula, if you notice, if you took out the x over 360 formula, it's the exact same formula as circumference of a circle. 2 times radius times pi. Notice, 2 times radius times pi. But then we multiply that with the fraction x over 360 degrees. 360 represents an entire circle, and x represents the measure of the central angle here. So as you could see in this problem here, where we're going to find the length of arc AB, you can see that the radius is equal to 2. And x, which is my central angle, is equal to 40 degrees. Okay? Remember, central angle is the angle that's in the center of the circle. It's created by a radius, 2 radii. Okay? All right, so that means to find AB, the length of arc AB, and the way that you represent that, you put the 2 letters AB, and then you put that arc symbol over it. It is going to be equal to 2 times the radius, which is also 2, times the number pi, times the fraction 40 over 360. Okay? And now what you're going to do is you are going to multiply these numbers out to get your length of arc AB. Okay? So 2 times 2 is 4. 4 times 40 is 160. So I think of 2 as 2 over 1, both the 2's is 2 over 1, and I multiply the numerators together, 2 and 2 and 40. That's 160. Then I multiply the denominators together, 1 and 1 and 360, which is 360. And so I get an answer of 160 over 360 times pi. And we're not going to multiply out pi, but what we can do is we can divide out the fraction 160 over 360, or we could reduce the fraction 160 over 360. And 160 over 360 reduces down to 4/9. Okay, so if you get a fraction, reduce the fraction, and then do not multiply 3.14 for pi. So there is my answer. So my answer for the length of arc AB is 4/9 pi. It's 4/9 of the number pi. Okay, moving on to the next example right here. We're going to find the length of arc DE. Okay, so we're going to find out how long is the crust from point D to point E, just the crust. Okay, notice that the radius is 6. X, which represents the central angle, is 100 degrees. Okay, I put the radius 6 and the x 100 degrees into my arc length formula. So I would multiply 2 times the radius, which is 6, times the number pi, which I represent with the pi symbol, will not use 3.14, times the fraction 100 over 360. So I'm just substituting in 6 for r and 100 for x into my arc length formula. Now I think of 2 as 2 over 1. I think of 6 as 6 over 1. You don't have to draw the ones, but it's beneficial if you think of that. And now I'm going to multiply it out. Multiply the numerator numbers. 2 times 6 is 12. 12 times 100 is 1,200. Over 1 times 1 times 360 is 360. So I get the fraction 1,200 over 360 multiplied with pi. And once again, reduce your fraction. Okay, you don't have to divide it out or anything. You just have to reduce it. 1,200 over 360 reduces down to the fraction 10 over 3. So that means my length of arc DE is 10 over 3 pi. Okay, you're always going to put your answer with pi in your answer. Don't multiply pi out. All right, so there is arc length. Arc length is how long is a piece of crust in regards to a pizza. Now we go to area of a shaded sector, which is the area of a slice of pizza. So what we're going to be doing in this problem is that they're always going to be given a slice of the circle that's going to be shaded in. And I am shading in the slice that we're going to find the area of. You might want to shade it in with your pencil if you have one. Okay? And we think of this as we're not finding the area of the whole circle. We're just finding the area of a slice of the circle, like a slice of pizza. Okay? And here is the formula on how you do that. To find the area of a shaded sector or the area of a slice of the circle, you take the radius of the circle and you square it. You multiply it with the number pi, which we represent with the pi symbol. And then you multiply that with the fraction x over 360 degrees. And just like in the previous problem for arc length, the previous formula for arc length, x represents the measure of the central angle. Okay, measure of the central angle. So, if you notice, this formula is the exact same formula as going all the way back to the beginning as the formula for area of a circle, radius squared times pi, except for we put that fraction x over 360. Notice, radius squared times pi, then it's the fraction x over 360. Okay, so in this first circle over here on the left, my radius is 10. My x, which is my central angle, is 60 degrees. I put the 10 in the place of r in my formula, and in the place of x, I put 60. Okay? So that means that my area of my section, of my slice, is going to be 10 squared, or 10 to the second power, multiplied with the number pi. We represent pi with the pi symbol. We're not going to use 3.14. Times then the fraction 60 over 360. Okay, now when you do this problem here, you're going to do it similar to arc length, except for we need to square first. So 10 squared is 100. So I'm going to get 100, and I'm going to think of that as 100 over 1, times the number pi, times the fraction 60 over 360. Okay, and I'm going to multiply this out, and I'm going to leave my answer in fractional form. So multiplying the numerators, 100 times 60 is 6,000. So I get 6,000 over 1 times 360 is 360. So I get the fraction 6,000 over 360 times the number pi. Okay, reduce the fraction, 6,000 over 360. Your calculator will do it for you if you're not sure how to do it, okay? So 6,000 over 360, let's reduce it long ways. The zeros will cancel out. That'll make 600 over 36, all right? Then I could divide, so if I'm reducing, I'll just do it over here. I'll do a little bit of work over here, okay? 600 over 36. I could divide both of these numbers with 6. That would give me 100 over 6. And I'm not done, because now I could divide both of the numbers with 2. And that would give me 50 over 3. So my area of my slice of my circle is 50 over 3 pi. Okay? Don't multiply out pi. Just put 50 over 3. Leave pi in your answer. Okay, but don't forget the pi, though. If you just say 50 over 3, that would be very incorrect. So it's got to be 50 over 3 and then pi. Okay, the next circle right here, my radius is 3. My x, which is my central angle, is 150 degrees. Okay, I'm going to plug in 3 and 150 into my formula to find the area of the slice of the pizza, which is shaded in yellow. So I'm going to go the radius, 3 to the second power, multiplied with the number pi, multiplied with the fraction, 150 over 360. Okay, 360, by the way, as we said earlier, comes from the entire circle being 360. 150 is the central angle. Okay, I have to square the radius first, so 3 squared is 9. So I'm going to get 9. Think of it as 9 over 1. You don't have to write it, but I will. You just have to think of it as 9 over 1. Okay, times pi times the fraction 150 over 360. Okay, and now I'm going to multiply. All right, 9 times 150. So I'm multiplying the numerators together. That is 1,350 over 360. 1 times 360 is 360 times the number pi. And then I reduce the fraction down. Okay, knock off the zeros. So I get 135 over 36. Not too sure if that could be reduced or not. You have a calculator. You could check it out. Start dividing. Yeah, that could be reduced to 15 over 4. Okay, we could divide both of these numbers with 9. So I get area of my shaded part is the fraction 15 over 4. Don't just put 15 over 4. It's got to be 15 over 4 pi. Okay, so there we go, you guys. So there is area and circumference and arc length and area of sections. Section 8.5. There's your notes, you guys, for 8.5.